Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your questions, and we'll get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we are going to be doing a drawing for two $50 Amazon gift cards, so please stick around. Hopefully you'll be one of our 2 lucky winners. All right, with that, we'll kick off today's webinar, which is solving the hidden costs of Kubernetes. Our speaker today is Austin Parker, who is Principal Developer Advocate, easy for me to say, at Lightstep. Welcome, Austin. Thanks for joining me today.
Hey, great to be here. Thanks for having me.
Awesome, awesome. Well, I am going to put myself on mute, let you get right to your presentation.
All right, great. Well, first, I guess, introduce myself to everyone and say thanks for attending. I know we're all weirdly busy still these days, even in these uncertain times, which I'm sure is a phrase that we all come to hate hearing. But a little bit about me before we kind of get going. As Charlene said, I'm the Principal Developer Advocate at Lightstep, and we are an observability platform built on distributed tracing and really meant for observing and understanding your modern microservice applications, or really any kind of application that you write or run on Kubernetes or any other platform. And we'll talk a little bit more about that kind of towards the end. So don't worry, this is not a pitch. Before I came to Lightstep, I worked in DevOps a lot, actually. I led a DevOps team at a company called Apprenda, and then did a lot of IT stuff before that, and I was responsible for kind of helping us build and run this complex platform as a service that was designed for enterprises, so that people could run sort of their big, heavy .NET or Java workloads on or off Kubernetes. And in doing so, that I had to deal with a lot of challenges that I think really now, this was 5 years ago or so. Now we're starting to see those challenges more broadly across the industry, and that's why I'm really excited to talk to you all about sort of some of the stuff I've learned over these years working in observability and working with Kubernetes. And so with all that said, you can see how to get in touch with me, or tweet at me, email me, but let's just kind of get into it and start off by talking about Kubernetes. So if I don't know how many people here, normally I would ask you to raise your hands, but I don't know how many people here are super familiar with Kubernetes, but just so we're kind of all on a level playing field, I want to briefly sort of address why Kubernetes, right? Why do we use it? And what is it? Kubernetes is an abstraction, really. It's an abstraction over things that are critical for running an application. Traditionally, if you have a bare metal, back in the olden days when dinosaurs walked the earth, when I wanted to run some software, I would need to go rack a server, install an operating system on it, and then install my application, right? That led to this idea of virtualization, where rather than having, one or maybe several applications running on a single physical server, now I'm able to take that physical server and sort of turn it into multiple logical servers through virtual machines running on a hypervisor. And each of those virtual machines could expose its own operating system, its own set of libraries that my applications would use. And that has given forth to this new idea of containerized deployments, where instead of a virtual machine that has its own distinct OS, I now have a bunch of containers that expose just the libraries that my application needs, and those Containers communicate through a container runtime to an underlying operating system. And this allows me a lot more flexibility in how I deploy software, right? Kubernetes helps out by giving an abstraction to all the other things that I need. Because it's not enough just to have an OS. It's not enough just to have, some dependencies that your application needs to run. You also need to think about, how am I scaling this application? What happens when my application dies? How does it restart? How do I know how many copies of my application are running? Kubernetes solves this problem for us, and it works really well. Kubernetes has made it super easy, I would say, in a lot of cases, for people to very quickly scale out and deploy a containerized distributed system. But all of that flexibility and freedom has come with some costs. There's still a lot of challenges you have to address when you're using Kubernetes. Kubernetes doesn't really make it easy to understand performance changes. So if I deploy a new version of a service running on Kubernetes, during that changeover, when I'm moving from version 1 to version 1.1, it can be very challenging to actually understand what's changing in terms of the performance or the latency or the resource consumption of my application at that moment. Even once I've fully deployed a new version of something through some sort of rolling update, how do I know that I've actually fixed the problem that I was trying to fix by rolling out that new version? Another big challenge, another thing that Kubernetes doesn't make it easy to do necessarily, is aggregating telemetry. Now, when I say telemetry, this can be anything from logs emitted from your service to sort of machine or container level metrics to newer forms of telemetry, kind of like distributed request tracing, right? And complicating this is that Kubernetes makes it very easy to generate a lot of this telemetry data. If I have a single service, maybe it's maybe I'm getting a gigabyte of logs per hour from that service. As I start to scale up though, and I have more and more copies of that service, now I have increasingly greater numbers of logs that I have to exfiltrate somehow, get to an analysis and processing system, and then I have to decide, how long am I retaining these logs? How, what's worth it? Do I need cold storage, hot storage? What do I do at that point, right? And Kubernetes makes it easy to increase the complexity that gets to this point of having to ask these questions, but doesn't do much to make it easy to answer them. Finally, let's pretend in our perfect world that we have all the answers, but we're still kind of at the mercy of traditional monitoring. Monitoring is great if you know what it is you're trying to monitor, if you know sort of the problems that you're going to have before you have them. But if you're in the woods and it's 3 a.m. and you're getting alerts that you don't understand, Kubernetes doesn't help a lot in terms of those unknown unknowns, right? And neither does traditional monitoring. So this is why people get stressed out by Kubernetes a lot, right? Kubernetes is adding this all these layers of abstraction and indirection and new and fancy technologies, but what those are really doing is that they are creating this depth, this sort of pyramid that you see here, right? At the very top, this is what I can control. This is the service that I or my team has some level of ownership for, right? This is where I can make pull requests and push new code and fix bugs. But there's all these other things that I'm dependent on. Now, these can be Kubernetes components. These could be managed services outside of my Kubernetes cluster. These could be things like container storage or software-defined networking or the Kubernetes control plane itself or my CI/CD system or legacy code or pick anything, right? But there's a lot of things that you can't touch in your Kubernetes cluster or outside of it that you're effectively responsible for, because if those things have problems, then you will have a problem because now your service is, throwing errors or being very slow. And that's stress, right? That is that you have that responsibility, but you don't have control over it, and that leads you to a pretty bad place. One of those places is these hidden costs, right? If you've worked with Kubernetes, or if you're starting to work with Kubernetes, or you're thinking about working with Kubernetes, then you might have seen some of these already, but let's kind of take a deeper look at three of them that we've identified, that I've seen certainly, and go from there. So the first cost, the first category of these costs are monitoring costs. Now, names change to protect the innocent on this tweet, but traditionally, when you are monitoring, especially time series metrics or log aggregation, um, you have a couple things to contend with. In log aggregation, you're contending with the volume of logs being created from your service. In monitoring, time series monitoring, you are dealing with cardinality, right? So the more complexity you add to your metrics, the more you get charged. Kubernetes makes it very easy to create new classes, new buckets that add up very quickly as you start to talk about this kind of, count times tags sort of billing. For example, in this tweet, as I expand my Kubernetes cluster, as I add more Kubernetes clusters, now I'm adding more tags that are then, for every request that comes in or every instance of service that gets deployed, I'm having to multiply the kind of matrix of possibilities here and add more and more and more cost to actually monitor what's going on. And as I scale up, now I have even more instances, even more tags, even more data points, which increase my monitoring bill. And that leads to usually a couple conversations that end up as, one, we're going to build it ourselves and try to save money, or two, we're going to stop monitoring things, right? We're going to reduce the complexity of our monitoring, and we're not going to, we're not going to monitor based on customer. We're just going to see like, well, how many requests are we getting, and bucket them by, pod or by node, and then go from there. But by reducing the resolution of our metrics, now we're less able to identify a problem kind of proactively, right? We have to be more reactive, or we have to spend more time doing investigations to uncover the root cause of a problem. The second hidden cost that you have to consider is sort of the service cost of understanding service dependencies. So Kubernetes makes it very easy to, add more dependencies to something, right? There's a lot of great tools like Helm or operators in sort of modern Kubernetes that let me go in and say like, oh, I'm going to add another service here. I'm going to add a caching layer. I'm going to start calling out to this external API. And if we look at the history of microservices over the past 5 years or so, the premium that you pay for building microservices has been significantly high all along, right? Martin Fowler talked about this, where even in the cases that you're going to want microservices eventually, you should start by building a monolith. And we're here 5 years later, and we still are saying, hey, maybe you should build a monolith. I think it's been interesting to see the sort of discourse in the community, because it's not just people like Kelsey Hightower, but you also, I think very recently there was an article or a blog going around from engineers at Uber talking about how they're kind of scaling into this idea of scaling back microservices, going to what they call macroservices, which are just bigger microservices. But I think everyone has seen what this is all reaction to is complexity, right? As I add more services, as I increase the complexity of my application and what calls what, I have just added more layers to that pyramid of stress that we showed a while ago, right? If no one knows how the sausage is made, then it becomes extremely difficult to debug issues, fight fires, improve performance, whatever it is that you're trying to do on a day in and day out basis, and that leads to a lot of cost. Finally, the third big hidden cost, I think, is this concept of bus factor, right? Kubernetes makes it very easy to do a lot of cool stuff, but all that cool stuff kind of there's a learning component too, right? I need to understand not only how Kubernetes works in a lot of cases, but I need to understand how Calico works or Rook or Raft or whatever else, right? All of these different consensus algorithms or container storage layers or networking layers. And when something happens, if major changes occur in the world and suddenly everyone's working from home, for example, or someone leaves the company, right? Or 40 billion other things. But I've personally seen, my last job I talked about a while ago, right? I was working as this big complex platform as a service, and we had built this very complex CI/CD system. And as people left that had built it, suddenly a lot of things that, oh, this is Jim's problem or this is Sally's problem, right? They know how to fix it, so we're just going to have them go do it. Well, Jim or Sally leaves, and now nobody knows how to fix things when they break. And you eventually kind of wind up with this very complex and tightly coupled set of services and infrastructure and CI/CD and everything else that's very difficult to unknot. And a lot of times what I've seen happen is people will say like, well, we just have to write all this off. We have to cut through, just cut the knot in half and rebuild it from the ground up. So ask yourself, in the services that you're building and the system that you have, how many people would it take to leave before you had to cut through the knot, right? How resilient are you in the face of externalities, that are unforeseen, like a global pandemic even, right? So there's a lot of questions that you get when you are using Kubernetes, and not all of these questions have easy answers. What I believe is the solution to a lot of them is really one word, and that word is observability. So when I say observability, what do I mean? Observability, it's not a tool. It's not like it's not a thing you can buy. Observability is a process. It's a practice, and it's how you understand your system. And that's any system. That's not just a system running on Kubernetes, but I think it's well suited for a lot of what we talk about when we talk about observability. And one question I often get is, what's the difference between observability and monitoring? Well, with modern software, with things running on Kubernetes or really anywhere, there's too many things that you don't know about until they happen. There's too many unknown unknowns, as we like to say, to accurately detect up front or to understand as you build your software. I'm going to quote from the new stack here. Monitoring really is about taking some assumptions and then freezing them in place and saying this is normal, and then using that fact that you've frozen this concept of normal and making sure that everything is always that, right? It requires you up front to say like, well, this is what we think, the amount of requests we're ever going to get is, or these are the use cases that we expect with this, or this is how many people we think will consume this service. And then you make those assumptions, you configure your dashboards, and suddenly it's very difficult to change them because you've baked in these assumptions, right? And if you think about, if you step back and you kind of step out of that mindset of like, oh, this is how it works, and consider, well, what if I just wanted to ask questions, right? What are the things that I might want to know about? Well, I might want to know about the logs and the metrics from my application. I might want to know about statistics from the kubelet, such as CPU or memory, and then I might want to subdivide that in some way, right? I might want to know per container, per pod, per namespace, cluster, so on and so forth. I might want to know about the resource utilization of each of those, containers. So how much memory on average am I using, or specifically? And I might want to know, what does a request look like, right? What's in sort of the critical path for a request through my application? Those are all questions. And observability helps you answer those questions, not by giving you a bunch of dashboards or not by giving you a bunch of tools to click through, but it provides you this comprehensive way of thinking about and understanding your system, your entire system, not just like a piece here, a piece there. It focuses on doing this by kind of solving cultural and process problems and by thinking about data in a different way, rather than just saying like, okay, go buy this or go install this, right? Now, I know that might not be super persuasive. I think we can illustrate it though by quantifying some of these costs we've talked about. So let's focus just on sort of the monitoring question, right? Like, what does it actually cost to monitor your system? Well, traditionally, there's two things. There's capital expenditure and there's operational expenditure. We can say that the CapEx here is how much does it cost to collect and store telemetry data? And then the OpEx is how much time are you spending per engineer to investigate what you've captured? So we'll do some quick math. If we take these factors, so we want to get some numbers around like how much does it cost to aggregate and index our logs per service, and then we need to think about storage, compute, network for actually capturing that telemetry data. We want to think about our peak instance count, so what's the maximum number of instances that we'll see, and then that would go into your formula. We want to think about a retention period, so how long are we keeping our telemetry data, and then how many services are involved in a request. You can take all of those things, add and multiply together, and then you will get something like this on the right side. So traditionally, when we think about logs, we think about or when we think about telemetry in general, we often think about it in terms of volume of data. So let's assume that our peak instance count and services involved gives us about 50 gigs of data a day, which is maybe a little high. For some people, it's certainly probably a lot low. There's not one good answer here, but let's assume 50 gigabytes of log data a day. Let's assume a 14-day retention period. And let's also assume that we want all this in high availability. So we don't want to be having to deal with swapping to cold storage or whatever. And then let's say, okay, we're gonna try to save money here, so we're going to use all open source software. So we're going to use, this is for Elk Stack or something, right? Elasticsearch, Logstash, and Kibana. So for 50 gigs of log data a day and a 14-day retention, your actual cloud costs aren't too bad. We need a compute optimized instance, 2 data processing instances, and then some SSDs. These costs I got here are from AWS. So if I say 50 gigs of logs, $716 of cloud spend per month to kind of process and store that, right? Sounds good. However, Elasticsearch, Kibana, all this stuff doesn't get set up for free. It doesn't get maintained for free, right? Patches need to happen. You need to tune parameters. You might need to expand capacity. You're going to need to spend engineering time. So if we add in that engineering time and we add in sort of the human cost of this, suddenly we've gone from our somewhat reasonable 716 to over three grand after setup and maintenance, which is a lot of money. Now, compared to some things, it might not be that much money, but that's still a decent chunk of change per month. So how did we come to this engineering time figure? So we're also going to talk about the operational costs here, right? Because it's not just, even if we assumed that everything was this 3 grand and you're good forever, that's not quite true, because you still have, you got this telemetry data, now you actually have to interpret it and use it to diagnose incidents. So again, we have our factors, how much does it cost for an engineer? How much time do they work in a year? How many incidents do you have, and how many people does it take to investigate that incident, and how long do those last? Once you've, outside of incidents, I mean, even as part of it, you're generally going to be deploying code or rolling back code. But outside of that, how many deployments are you making in general? these are all the questions you have to answer to really figure this out. So we're going to make some assumptions about values. So let's say that it costs on average over $200,000 a year for a software developer. Now this is averages based off of Bay Area US salaries. So your mileage may vary depending on where you are, but let's use this as a nice, somewhat round number. I think we got this from levels.co. If you assume each engineer is working about 2,300 hours a year, which is slightly over 40 hours a week, that gives you an hourly cost of $89. If you assume that each engineer is going to have about 10 incidents they respond to, and then it takes about 4 hours to investigate that incident, and then beyond that have an additional 50 deployments a year with about 30 minutes to actually make sure that, hey, things worked, or I've fixed the problem, or I've accomplished the goal that pushing this code was supposed to, then that gets us to these numbers. So generally, in my experience, if there is an incident, if there is some sort of disruption to service, it's not just one person fixing it, right? You generally have a team. So we kind of model this average size software company with about 60 software developers, and let's say that for an incident, it takes 10 of them, or 10 of them get touched in the resolution of this problem. So at 4 dev hours per incident times 10 people, that gives you almost $3,600 every incident. Now, when you start playing around with these numbers more, then you get some really interesting things, right? Like just in terms of validated deployments, if we assume that every developer is doing these 50 deployments over the course of a year, then that's almost another developer. That's almost a 61st developer in salary, just making sure that, hey, things worked after I pushed this code. And that doesn't even necessarily mean I deployed a new version of a service, right? That could mean I'm integrating something into trunk from a feature branch, or I am merging this PR and I need to make sure it gets through tests. There's a lot of things that deployment can mean, right? But the one factor that all these things have in common is time. What we've found, at least at Lightstep, and just me personally talking to people, you can't control a lot of these other factors. I can't go and make, cloud instances cost less. And for the most part, neither can you. And even if you can, you're really playing around with the margins. The one thing you can control, though, is how long does it take to do these sort of tasks. So what we've found is that effective use of observability as part of sort of a transformation of a team from traditional monitoring into sort of observability mindset can really take these numbers and cut them down a lot, really by a factor of 5. So instead of our $3,500 or so per incident, now we're down to $712 per incident. What's really remarkable is that $133,000 of time spent validating deployments is cut massively, to 26 grand. And this is solely because rather than spending half an hour to make sure something's worked, you can spend 5 minutes or less. So you might be saying, wow, that sounds great. How do I do that? Well, the answer is through this concept of holistic observability. The key goal of holistic observability is to utilize context as a mechanism to control your costs. Now, you create this context in two ways. One is by improving the communication between your teams, between your developers, right? Rather than everyone having kind of their own, vanity metrics or their own way of describing performance, observability says, hey, let's have shared terms, right? Let's not and I will say, if you're familiar, like if you've read the Google SRE book, some of these might be familiar to you. And I'm not saying everyone needs to go out and start doing 5 whys or start doing, error budgets, but being able to describe, kind of our shared goals as like, hey, this is our objective. This is our service level objective. These are our service level indicators. And having those be consistent throughout all your teams gives you this kind of shared context to let people know like exactly what are you talking about when you say like performance is good or performance is bad, right? We can use this to know, are we trending in the right direction or not? This can also help address things like alarm fatigue, where everyone has on the same playing field. Instead of having to kind of figure out this is the metric that's important for this application, that's the metric that's important for that application, it lets us focus on, well, we care about latency, we care about throughput, we care about error rate, we care about the golden signals. And when there is a disruption or there is an incident, we can quickly focus on what's important rather than having to go through Confluence for an hour trying to figure out like which dashboard should I be paying attention to, why do these logs look different than those logs, how do I actually get useful debugging information out of this system. This is what we mean by sort of this communication context. We save time, we set goals more effectively and more efficiently. The other context is this data context. So we talked about logs earlier, right? And one cool thing about logs is maybe traditionally you'll think of logs as a separate thing, right? As like I have logs and I have metrics and I have traces and I have these 3 pillars. But when you think about it, log data is just another type of telemetry, and all these types of telemetry, especially if they're properly if they're structured, can be converted. So if I have a logging statement, and you can probably think of a simple example of this right now is, if you're familiar with Apache or Nginx or whatever, right? You take a log file, an access log file, and an error log file, and you pipe them through something, and that creates a time series of successful requests versus unsuccessful requests, right? I've converted my logging statements into a metric. If I have some sort of correlation context, a request ID or something in those logs, then I can also make a trace. I can also see, here's how this request moved from the load balancer into a API proxy into another service. So observability is built on this concept that this data is all sort of fungible in that fun little way. So rather than having separate dashboards or 3 separate experiences, observability says, let's take all that and let's put that into sort of one tool and build insights out of it. So use traces to narrow the search space to relevant metrics and logs so that instead of looking for a needle in a haystack, you're able to very quickly jump to, like, okay, here's the problem, here's where it's occurring, here's the exact cluster, here's the exact pod that's failing, here's the exact node that's having a problem, here's the exact region that is, under load, or even saying, this is the customer that this is affecting right now, right? So that efficiency that you get through having strong data context doesn't just save time when you're investigating an incident, but it also reduces kind of the storage and processing costs of actually sifting through this data, which is another cool side effect. So you might be sitting here saying, that all sounds great. How do I actually get it? How do I implement this? So there's really 3 keys, and I'm going to kind of wrap up talking about these. And the 3 keys are, you need to make sure you have observable services. You need to focus on your key SLIs, but make sure your SLOs focus on business goals. And you need to put people at the center of what you're doing with observability. So for observable services, you should focus on sort of open source telemetry platforms, or sorry, not platforms, but SDKs, right? A lot of people are out there building kind of their own bespoke, tracing or whatever tools. As a maintainer of OpenTelemetry, I'm going to say, hey, no, you should use OpenTelemetry. So the idea with OpenTelemetry is that it is going to make, the goal is to make this sort of tracing and metrics and things like that a first-class citizen of your cloud native software. So in the future, right now, there's an integration into Kubernetes through, there's an operator available so where you can add the OpenTelemetry collector to your services. I expect that in the pretty near future, but I don't want to put words in anyone's mouth, but I know there's a lot of interest in actually integrating OpenTelemetry into the Kubernetes control plane so that you would be able to get this telemetry data about the performance of your Kubernetes cluster, which would be very cool. Today, you can use technology like Istio, service meshes to really quickly bootstrap this without having to modify your code. And then you can also integrate OpenTelemetry into your application code itself and programmatically add that in there by, importing the OpenTelemetry libraries and then wrapping, your HTTP services or your gRPC services. If you want more information about OpenTelemetry, you can find it at the OpenTelemetry website, which is opentelemetry.io. That project is in beta. Again, there's more information available on the website, but this is sort of the foundation. You need to have observable services. The second thing, once you have observable services and you're able to actually understand what's going on, is you use that data to create effective SLOs. So out of the box, if you're using tracing, then you will get your golden signals will be measured. So the latency, the throughput, the error rate of your service will be there without really any other work. Take those and then use that as sort of a factor to when you're thinking about service level objectives. So it's more important with a service level objective to think about like what is the impact this has on the end user. So for example, I say here, when I try to play a song, it plays, but you can also think of it as when someone is requesting this API, I will send them a response in under 200 milliseconds or under 10 milliseconds, right? When someone tries to add an or item to their basket, to their shopping cart, they will get a successful or a failed response in X amount of time. And that practice of talking about SLOs as in things that are maybe relevant to the business not only helps you, it gives people a very easy touch point to say like, oh, okay, I can understand this, not only within engineering teams, but also, outside of engineering teams, to your product people, to your designers, to sort of business analysts and people that aren't in the day-to-day of creating software. Because people might not understand, I have this health check, endpoint, and I have 4 or 5 nines of the health check endpoint, but it doesn't matter because when someone clicks this button, it's still slow, right? So if you focus on sort of actionable end user things in your SLOs, then it becomes easier to communicate not only when you've hit them, but also when you have failed them, right? And helps you restore performance to those more easily. Finally, you want to keep this focus on people, right? You're getting all this data, you're instrumenting your software, you're observing your Kubernetes cluster, it's all great, but what do you do with it? So I've found what's very effective is that you bring this data back inside. If you are listening to this and maybe you're running a platform team or you're disconnected somehow from the developers that are writing code, being able to say like, hey, we should be looking at this telemetry data and using that when we figure out what we're going to work on next, right? In sprint planning, that's super useful. When you have a retrospective or you have an incident review, being able to point to like, well, here, being able to point to the telemetry and say like, well, here's when we saw the problem, here's where we saw the problem, here's the difference between before or after the deploy that caused it. Having that data actually, I find, kind of reduces hurt feelings because everyone can agree that the data is the data, ideally at least. specifically around Kubernetes, oftentimes having that data and having that observability practice can make what's going on in Kubernetes a lot more accessible and easy to understand, especially if you integrate this into sort of your deployment or into Kubernetes more deeply, and you can see, hey, this is exactly why it takes this long to build this container or scale this service out because of, of whatever, right? Maybe I have maybe I have a lot of heavy dependencies in my deployment. Maybe I'm needing to spin up an entirely new cache for each pod, whatever it is. Observability and kind of integrating that observability away, not even at the service level, but also at the kind of CI/CD level, can really help you in teaching people about, like, hey, this is actually what's going on behind the curtain, so to speak. Ultimately, what we're trying to do with Kubernetes in general and software in general, right, is we want to make these hard things easy. We want to see the impact of our changes. We want to make sure that as we do work, as we, solve problems, both for ourselves and for our coworkers and for our end users, that those problems, those changes are actually making an impact. And observability makes it very easy to understand what the exact impact is of your changes on your end users, be those end users, actual kind of people sitting at home watching, watching a movie or doing whatever they are with your application, but also your colleagues, right? They're the people that are sitting at another desk or in their house trying to understand, like, what is going on when they try to, deploy a new version or understand what the additional, cost is of adding this dependency or using this new managed service versus a different one. So that's what I mean about focusing on people, though. Think about how this is actually impacting the people that are using it. And observability, I believe, is the key to that. So with that said, we have plenty of time for questions, and I would be happy to take them.
Excellent, excellent. Well, let's see. We do have plenty of time for questions. Yes, you're absolutely right. So if you do have a question, please go ahead and use your GoToWebinar control panel and submit it. And let's see, we do have one comment in here. I guess we could start with that. I haven't heard reference to observability insights provided by Prometheus tools, or the Prometheus tool. Any thoughts on that?
I'm not 100% sure what the I would need more clarification.
Okay.
Sorry.
All right. That's fine. That's fine.
If
We'll
you
go
want
ahead.
to rephrase that, I would appreciate it. Or
Yeah.
whoever commented.
Yeah. Yeah. Go ahead and just put any clarification that you might want to add into the control panel, and we'll get back to that one. Next question here. Is it best to leverage different tools for metrics, logging, and tracing, or should there be one tool for all three?
It's a great question. I think to kind of go back to what I said earlier, all this data is really transformable from one format into another, right? Like, I'm a little biased here, because Lightstep's whole thing is that we don't think you should have different dashboards. You should have sort of a single platform that integrates all these different sources of telemetry and then uses them to give you actionable insights. I've put up the slide for it. If you want to try that out, we actually do have a free trial. You can go to go.lightstep.com/trial and try it out for yourself. And I think that's very useful to kind of see the difference. But traditionally, people will, or what I've seen at least, is you'll have, one dashboard. These are all your time series metrics. You'll have another kind of search tool where you go in and you look at your logs in, Logstash, and then maybe you'll have Jaeger or Zipkin or something for traces. And what hurts is trying to manually do the correlation across all those three things. It's very easy to get lost. It's very easy to miss something critical. So personally, I think you're going to be more productive if you are using a tool that lets you see all this sort of stuff in an integrated fashion and is building those kind of insights for you by looking at the data rather than having three separate experiences.
All right, great. Next question. Do you have any recommendations on preferred observability tools for Kubernetes based on your experience?
That's a good question too. I think if you're just getting started, like if you already have Kubernetes and you're really interested in quickly seeing application performance under Kubernetes, then tools like Istio, service mesh tools are a great way to get started because they'll let you generate, traces very quickly. And also they'll give you an easy way to access metrics, container metrics and sort of integrate that for you. And they'll also do it in an open source way, right? Like if you have Istio, then you can get, um, I think it actually comes with kind of Grafana and will show you nice dashboards for some of this stuff. Obviously, if you want to take that and you want to get more advanced with it, you want to go to a proprietary solution, since Istio is built using open source technologies, you can take that data and feed it into Lightstep or any number of other tools to get that more integrated experience that we just talked about.
All right, great. The next question here, what role will machine learning play in understanding your data or helping solve the complexity problem?
That's another really great question. Thank you for asking it.
Really good
So I,
questions today, huh?
yeah, no, this is great. This is what I like. I like the Q&As. I think it's more interesting. So I think ML is interesting in this because there's a lot of marketing right now around like AI as sort of the panacea to these problems, right? We assume that if you feed enough data into an algorithm, it will return some sort of base truth. I don't necessarily agree with that just on the fundamentals, because what we've seen is that what ML and AI, what ML does at least, is it will accentuate biases that already exist. And I think this is kind of the problem I talk about with monitoring. Um, Monitoring requires you to go in and sort of know what you care about beforehand. ML, if you just feed data into ML, all it's going to do is it's going to effectively normalize the things that are already happening and then tell you when something is different. But if you've gone into this and you've sort of made incorrect assumptions to begin with, then all ML is going to do is it's going to normalize those existing assumptions. I think a good example of this is I talked to a customer of ours a while ago that started using Lightstep, and what they found very quickly was that there was a service they had that the performance was never great, but they just kind of assumed, oh, this is how it is because we're doing something really complex here. What they found by kind of visually looking at some traces was that, oh, we actually have a bug where we're making this database call like 5,000 times and we don't need to. Now, if you had taken that data and put it into a machine learning algorithm, all it would have done is said like, oh, well, it's working, so this is probably what it's supposed to be, right? And maybe you would have gotten an alert like, oh, well, now you're making 6,000 calls, but the machine learning model doesn't know that you should have only made 5. That's something that really you only know as a developer. However, I think there is a large role for just sort of like math and like heuristics and statistical analysis in this sort of field. And I think if you dig into it, what you'll find most people talking about like ML and AI in sort of observability are actually doing is just using those sort of mathematical formulas and heuristics and aggregate analysis, and then saying it's ML or AI as a marketing strategy. But that is my personal opinion. Um,
All
I hope
right.
that was responsive.
Okay, definitely. Okay, great. Plenty of great questions in, but there's still time. If you do have a question for Austin, please go ahead and use your GoToWebinar control panel. And if we don't get to all the questions, please know that Austin's going to be getting a copy of them. So I'm sure he or somebody from Lightstep will be more than happy to follow up with you offline. So don't not ask because you don't think we're going to get to it. So, okay, next question. For a company planning to use Kubernetes starting in a few weeks, what would you recommend is the best beginner's guide that includes your guidance?
um, Company that starting in a few weeks, what was the best beginner's guide is? That's a good question, and I actually don't have a great answer for you right now, because there's two reasons. One, there's a lot of factors, like are you going to be using managed Kubernetes, like GKE or something? Are you going to be rolling it yourself? I think what helped me a lot personally when I started using Kubernetes was Kelsey Hightower published Kubernetes the Hard Way, which is really just like how do you build a cluster, which I found really useful in kind of understanding how it all fit together. But outside of that, I think the best answer actually would be we can follow up if you email. We can get some more resources for you or just start the conversation because like I said, there's so many factors. Like Kubernetes has changed a ton over the past couple of years, and the things that were a good answer to this 2 years ago are not a good answer today. And so I would rather not, lead you astray.
I could do a shameless plug also for our Container Journal website, which focuses on Kubernetes quite a bit. So you can always get the latest information on that website.
Yeah,
So
absolutely.
there you go. Okay, next question. Should microservices be designed as microliths or macro services to balance complexity and operations management?
It's a good question as well. I think it really depends. So the advantage of microservices, in my opinion, has never really been about there's nothing particularly like novel or unique, right? Like before microservices, we had SOA, we've had other things before that. Ultimately, the question of how big is your service is going to depend on kind of two big factors. One is what is sort of the organizational complexity you're dealing with? Um, how big is your application? How many teams working on it? Are those teams kind of divided by geography, time zone, so on and so forth? How much legacy stuff do you have to interact with? Because if you have, if you are building an addition, or what I like to call, if you're gentrifying an existing sort of line of business app, then it might make a lot more sense to do slightly larger services in order to more cleanly kind of divide stuff off of your existing, legacy backend, right? That way, instead of having to now, effectively, what you're doing is you're just going to be building a newer version of the old monolith, but that newer version of the old monolith will be a little bit more easy to decompose later if, again, sort of the organizational questions change and you're able to, now you have to subdivide it even more. The key takeaway I would say is you should build the right size for the amount of people you have working on it, how quickly you need to release it, and how easy it is to release new versions. Because if you're too big, if your service is too large and it's hard to actually, roll out a new release, then it's too big. You should decompose it more. But if you're spending more time trying to do releases and integration testing and UAT and stuff like that, if you're not able to effectively test in production, then maybe you're too small and you need to add some more bulk because you've made it so difficult to actually deploy software that you can't quickly adapt. Hopefully that was and 40 billion other things. Like we could talk about just that, like that one topic for an hour by itself. It's a very interesting one. I really like it. So thank you for the question.
All right, great. Okay, we're about 7 minutes to the top of the hour. I think we have time for one more question. So here's what I think is a good one. How can distributed tracing be done in Kubernetes if there are multiple Spring Boot applications running?
That's a good question. If you have, if they're all part of the same request, then there's a couple different options. The easiest is to use something like the some sort of Java automatic instrumentation. In OpenTelemetry, there's a Java auto instrumentation project that will work with Spring Boot. If you're still on open tracing, there's the Java special agent. And what those do is sort of runtime bytecode manipulation to add in tracing to Spring applications. At a higher level, all they're doing is when a request comes into your app, it checks to see if there's tracing headers. If there is, it creates a new, it continues the trace. If there's not, it creates a new trace. And then when you make an outgoing request from that service to another one, it will inject those tracing headers into the outgoing request. And then on the other side, the same thing happens. It looks for the tracing headers, extracts them from the request, makes a new request or makes a new span, and then all of these services are kind of creating their own spans as part of this trace independently of each other. On Kubernetes, you can use, if you want to use OpenTelemetry, the OpenTelemetry operator will put a OpenTelemetry collector everywhere, depending on how you configure it. So you can have just like a known place to send all that telemetry data to, that trace data to, and then from those collectors, then you can export it to your choice of backend, to Jaeger, Zipkin, or to Lightstep, or to wherever you want. The nice thing about OpenTelemetry is it's vendor neutral. I hope that
All right.
was responsive.
Excellent, excellent. Okay, well, we're about 5 minutes to the top of the hour, so I'm afraid that is all the time that we have for question and answer. I do want to thank everybody who did submit questions, and as I said earlier, if we didn't get to your question, I'm very sorry, but please know that the folks at Lightstep are getting a copy of all of the questions, and I'm sure somebody from the organization will be more than happy to follow up with you following today's webinar. Also want to remind the audience that today's webinar has been recorded. So if you missed any or all of it, or if you just want to watch it again, you will have the opportunity to do so. We are going to be sending out an email later on today that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website. So you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Also, before we close things out for the day, I know at the top of the hour I promised to do a drawing for two $50 Amazon gift cards. So without further ado, let's go ahead and get to that. Today's first winner is Scott A. Congratulations, Scott. And our next winner today is Thomas B. Congratulations, Thomas. We're going to follow up with both of you guys offline by email to get your gift card over to you. So please check your email for that. And I guess that right now just leaves me to say thank you to Austin for such a great presentation. I can't believe how many questions we got in, which is a great indicator of how well the webinar was received. So congratulations, great conversation.
Thanks, it was great to be here. Have a great afternoon, evening, morning, whatever time it is, wherever you are.
Whatever, yeah, there you go. Also want to thank the audience for joining me today. And this is Charlene O'Hanlon signing off. Have a great day and please stay safe.